Hey guys, welcome to day 15. I think we're going to wrap up chapter 2 today. One of the last sections in the text has to do with problem solving. You might want to go back and look at some of the pages in the back of the book. Anytime I put page numbers in the notes, that's usually a good indicator that that stuff may or may not be in some of the quizzes. So page 955 might be a good place to look. All right, so this is the way the kind of book breaks down problem solving. It's really just a logical approach. Anytime you're doing a problem, just read the problem first. Identify what is known. Do I have speed? Do I have time? Do I have distance? What is it that they gave me? Then you're going to identify what is it that you're trying to solve. I usually underline that or highlight that if it's a word problem. Sometimes you have to break problems into simpler problems, and you might need to look up constants, equations, or conversion factors. But in the homework assignments, oftentimes I will give you the equations and many times the conversion factors as well. All right, sometimes you need to calculate some things. You might need more than one equation. You might need to be able to convert measurements. Maybe I give you something in grams and you need to convert it to kilograms. I think you have to do that in tonight's assignment. Also, when you're all said and done and you've answered the questions, you have to evaluate it. Does it make sense? Is this a humongous answer? Is it really small? Is it reasonable? Sometimes that's easy, sometimes it's not. One thing I want you to be on the lookout for tonight is sig figs. And remember, the factor with the lesser number of digits is the one that determines your sig figs, okay? So also, if it's a big number or a small number, you might want to consider scientific notation. Expressing as an ordinary number is always okay too. Guys, always go back and recheck your work. All right, these are other tips. These are kind of from me. You might want to phone a friend. You might want to do an internet search. Always look in your textbook. Look in your notes. Know how to use your calculator. Order of operations is clearly important, okay? One of the things we're going to focus on today is rearranging equations. So rather than go through examples in the notes, I think I would rather kind of do some of the problems that were in the homework. So you'll have to rearrange some equations in the Google Forms, and it's just things that you've been doing for years in algebra. Hopefully you know how to do it, okay? All right, and of course, don't forget order of operations, PEMDAS. Parentheses and exponents always come first. Multiplication and division always come next, and addition and subtraction usually come last. All right, so what I'm going to do with you here is I'm going to just kind of rearrange some of these equations and solve some of these problems. And in the case of number one, we're going to be solving for x, okay? They kind of go from easy to more complicated. So for the first one, we want to solve for x. And the way that we're going to do that simply is we're going to get x on one side of the equal sign and everything else on the other. And the way that we're going to do this for the first problem is we're going to divide both sides by y. And when we do that, y cancels out y. And I'll rewrite the equation for you. K over y is equal to x. So we have rearranged that equation for x, and that is going to be my final answer. Let's do another one. All right, d equals x over t. Remember, we want to get x all by itself. So in this case, we're going to multiply both sides by t. And when we do that, t cancels out on the right, and we get a new equation, td equals x. Okay, done. Let's do another one. All right, a little bit more complicated here. Y equals mx plus b. So for this problem, I'm going to start by getting rid of the b. I'm going to do that, and I'm going to say minus b on this side, minus b on this side. And I'm going to rewrite it. Y minus b equals mx. And the plus b minus b on the right side cancel each other out. Now I want to get x all by itself. So now what I want to do is divide by m. But I have to divide the whole left side by m, not just one of those factors. M and m cancel out on the right, and I am now left with a new equation, y minus b over m. And remember, you have to divide this whole quantity, y minus b over m. All right, let's keep going. All right, so now we got x on the bottom. This makes things a little bit more complicated. We don't want x on the bottom, so what I'm going to do is I'm going to put the p plus 4 in parentheses, and then I'm going to multiply it by x. But whatever I do to the left side, I have to do to the right. So x cancels out, and I'm going to rewrite my equation, xc equals the quantity p plus 4. Now, I want to get x all by itself, so I'm going to divide both sides by c. And when I do that, I come up with my final equation for x. Oops. X is equal to p plus 4 over c. Probably didn't have to use parentheses, but it doesn't hurt in this case. All right, I'm not going to do the last problem with you, but I am going to go back and do this one with you right here. So we want to get x all by itself. The first thing I'm going to do is I am going to put everything in parentheses here and there, okay? And then what I'm going to do is I'm going to multiply both sides by x plus 1. And when I do that, I've basically changed colors on you here. I've basically removed the h plus 1 from the right side of the arrow. Now what I'm going to do is I'm going to go back and I'm going to rewrite it down below. Now I could distribute this r, but I'm not going to. So I'm going to rewrite the equation to kind of clean it up a little bit. X plus 1 times r is equal to x plus 2. And in this case, I'm going to go ahead and get rid of the parentheses because I don't really need them anymore. And what I'm going to do to this side is I'm going to subtract 2. And whatever I do to one side of the arrow, I have to do to the other side of the arrow. So I think this is going to cancel out, and we're going to be left with x all by itself. And I made a mistake. Checking my work as I'm going along. This should have said h plus 1. All right, guys, I'm just going to go ahead and stop that one, and I'm going to move on to the next problem, okay? Sorry about that. I made a mistake. Don't really feel like going back and re-recording the whole video. All right, so let's do a few down here. Calculate the mass of an object that has a density of 18.3 and a volume of 873. So I look up here, and I see two equations for mass. I see an equation here for mass, but I also see an equation for there for mass. And when I start digging in a little bit deeper, I am given density and I am given volume. So I think that I am going to use the circle form of the density equation. Now I'm solving for mass. So I guess what I need to do first is rearrange my equation. M equals D times V. And when I plug in my numbers, my density is, I'm going to put it in parentheses, 18.3 grams per centimeter cubed. I'm showing my units, and my volume is 873 centimeters cubed. Now, I'm not going to solve this for you, but I did want to show you a few things. I wanted to show you how I got to my equation, but I also want to show you that unit cancellation remains. So when I'm going to take my calculator out, I'm going to do 18.3 times 873. Centimeters cubed cancel out, and the unit that remains is the gram, which is appropriate because I'm looking for mass. Now, for this particular problem, I'm going to get a big number, and I'm only going to be allowed to keep 3 sig figs. Both of my factors have 3 sig figs, so my answer can keep 3 sig figs. All right, I'm not going to do letter B with you, but I am going to do letter C. What is the mass of an object that has that requires a force of 1.2 times 10 to the 3 newtons to accel it to a rate of 5.1 meters per second? So once again, we're going to go up and we're going to look for equations for mass. And in this case, I've got force and I've got acceleration. So if I rearrange this equation, F divided by A is equal to M. And my force is 1.2 times 10 to the 3 newtons, or 1,200. And rather than putting newtons in, I'm going to put kilograms and meters per second squared. You'll see why in just a second. And then I'm going to divide that by the acceleration, which is 5.10 meters per second squared. And now I think you're going to see why I decided to use units. So meters per second squared and meters per second squared cancel each other out. And my final unit of my answer is going to be in kilograms, which is an appropriate unit for mass. I have 2 sig figs on top. I have 3 sig figs on the bottom. So when I take 1,200 and I divide it by 5.10, I can only keep 2 sig figs as my final answer. All right, final one for the day, guys. How much power is generated? So I have to look up here, and I only see one equation for power, and energy is equal to power times time. So if I rearrange this equation, energy over time is equal to power. Okay, let me just go back, double check my work. Energy divided by time is equal to power. Okay, then I'm going to take my power, which is, my energy, which is 2.074 times 10 to the 4 joules. And I'm going to divide that by my time, which is 9.58 seconds. And I'm going to get a number. Now, guys, what your answer is going to be is going to be in joule per second. And just so you know, a joule per second is a watt. So joules divided by seconds is joules per seconds, which is equivalent to a watt. I have 4 significant figures on top. I have 3 significant figures on bottom, so I can keep 3 sig figs in my final answer. I realize I didn't actually do the calculations with you. Guys, you're simply multiplying and dividing, but what I did do is I rearranged the equations. I gave you clues as to the sig figs, and you're going to have to do that in your homework tonight. All right, so guys, don't forget to complete the Google form. If you have any questions, you can email me or you can leave a comment. I miss you guys. I love you guys. I'll talk to you soon.